Hi there, and welcome to Part 3 of Appendix C, Graphing with MATLAB, from Stevens' Matrices, Vectors, and 3D Math, a game programming approach with MATLAB. Here we're going to grab a program out of this repository, the Appendix C zipped collection of files found from the textbook website, and we'll show you specifically in this particular demonstration how to create animations. The previous demonstration had plotting using the plot command. Now we're going to use the plot command to create animations in 2D. And before I get that started, it's worth pointing out that it really is not that hard. The process, the code you're about to see is going to be a lot bigger than this because there's some details to fill in. But basically, the animation is just a for loop, right? And you create the original plot, you give it a name, you update something about the plot, put a little pause in there so that it doesn't go so fast that you can't see it, and then you delete the ball plot, right? And then what that does is as soon as you delete, it goes right back up and plots the new one. Right, so there's very little gap. So long as you delete last and plot first, the gap is really small. Right. Okay, so let's see an example. The demonstration in that program repository is called Bouncing Ball Animation. So you want to grab that, open it up. I have my window set up so that my figures are off to the right. My command window is actually tabbed with the program editor. Bouncing ball animation. So the first thing I'd like you to do is just run it. So we're going to run it, and what we have is a ball here, and it's going to bounce along following this trajectory, right? And we're going to click to start it. So click, and the ball bounces along that trajectory, which I made it disappear. Okay, so how did we do that? Okay, so the first thing is with all my code, I start off with a clear the command window, clear the figure, and then clear actually also clears all the variables. You don't always need all of these at the beginning, but I usually do it because sometimes a lingering figure or variable will confuse what you're trying to do, or you'll see a figure and it'll be like, where did that come from? And it's actually just a remnant from a prior program. But I usually start off my codes with this. Okay, so the next thing on this code, this is the path. And when we ran this, the path I'm talking about is this black curve here. And what that is that's just a decaying exponential curve multiplied by a sine. So a decaying exponential curve with a sine wave embraced in it would go up and down, a decaying up and down that would go below 0 and above 0. It'd be like curve, smooth curve up and down. But I don't want it to go below 0, so I just use the absolute value of the sine. So wait, this is basically just a slowed down sine curve by 0.5, right? So I double the period. I take the absolute value of it so that it has that bouncing look, and then I decay that bouncing by multiplying that by an exponential, right? And this is just one of those anonymous functions we learned about a couple videos ago where you use the @ the input variable is x, and then the output is in square brackets. So that's my path, right? Okay, and so what I'm going to do is I'm going to set this up. The first thing I'm going to do is have 300. That's going to be the number of time frames that's going to go from the beginning to the end of this animation, right? And so the first thing I do is I create my path. So x will go from 0 to 35. That's down here. And then my y will be path of x. And path is that anonymous function I defined up here. And now I have to create that ball, the circular ball down here. So that's going to be a parametric function. T is going to go from 0 to 2 pi. We'll make 100 points in there. So we go the whole way around the circle. The x values of the original ball, this one sitting here right there, is 2 times the cosine of t. The y value is 2 sine of t. So it's just a circle with radius 2 centered at the origin, right? And so the original plot, before I click anything, I first have the path plot, which is just x and y, right up here, x and y. I hold on because I'm going to plot some other stuff. I don't want it to disappear. And then the ball plot, I'm just going to use that same plot command. original ball, original X ball, original Y ball, right? With a red line. So that gives me my red circle. I have a title, and I make sure my axes are equal so that my circle, my ball there, looks circular. And then I bound my axes with the axis command. So X is going to go from -2 to 37 because the radius of the ball is 2. I don't want it to fall off the graph. My Y goes from -2 to 20. Right? So that's my initial plot. That's what I'm looking at right here. And then I have this command called wait for button press. And what that does is this program, when you're running it, it stops right there. And it won't do anything until you click. You can actually press any key on your keyboard, or you can click the figure. All right, so we put in the title, and then as soon as I hit button, as soon as I click that thing, the title will change, and I will delete that path plot, this black line. So all of this was just set up, right? The actual animation starts right here. And it's just a for loop. I'm going from 1 to n, and I defined n way up here, 300. That's my number of time frames. And so I'm going to update my x values, right? And what that means, I'm going to take that original ball, all those x values, and I'm going to add xi. That's the trajectory x. Remember, x and y define that black line. So those are the points on that black line. So if I take this ball and add some point from the black line to the x and the y value from the black line to the y, this ball will move up along this trajectory, along this curve. And so that's what I'm doing here. I'm taking my original x and y, and I'm adding the x and y from the trajectory. All right? And so then, so that my animation is smooth, I delete that ball plot, and then I immediately replace it with the new one, with the updated x ball and y ball. And then I pause. All right. I do that 300 times, and that'll get me from beginning to end. And notice that the reason I know it goes to the end is when I created my x values, I know there's 300 of them. So when I go through this loop 300 times, I'll be at the end of this black curve. All right. Okay, so now I'm ready to just wait for button. It's still waiting for my button press. When I press it, bink, the trajectory disappears, and the ball appears to be bouncing down the runway there. Okay, so there's a lot of setup, and a lot of that goes to our previous videos on how you create that trajectory curve, how you create the ball. But the animation stuff is really just right here. What you want to do is update the graph, and you can actually create the ball. I already had a ball plot going, so sometimes you might start with the ball plot and then update it and then delete it and do it over. But in this case, the key thing to do is make sure that the delete, when you delete the current one, that the next one is right away. That way you don't have any blank time without any plot, right? And it looks very smooth. So when you run the whole thing, it sets up an initial graph. It waits for a click to sort of start the animation. And there are a lot of files in this program repository that are animations, and it generally follows this setup where there's an original graph and you click the graph to start the animation. Alright, so that's animations with MATLAB. It's pretty easy. It's really, it seems more complicated once you start trying to make it pretty and add some bells and whistles, but it's really just a for loop. Alright, that's all. See you on the next video. Bye.